Okay, so now that we know how to graph an equation using an input-output table, as well as x and y intercepts, now we're going to just take a minute to identify how we know an equation is in fact linear. Then we're also going to calculate slope as well as rate of change. So a linear equation, in fancy terms, it has an exponent of 1. So I'm going to put exponent of 1. But more so, okay, when graphed, graph is a line, a straight line, okay? Now slope, we know it's kind of like a multitude of things. So it could be rise over run. It could be looked at as your change in y over change in x. Or it could be the change in your dependent over your change in independent. And that's kind of where rate of change comes into play, okay? So it is your rate of change is still slope, okay? However, now we're talking about the change in your dependent variable, so it's your y, all over, okay, maybe I'll put that in parentheses, your y value, all over the change in your independent. So an example of a linear equation, there's many examples. I can do something like y is equal to x. There my exponents are 1. I could do something like y is equal to 1/2 x plus 3. But notice how the only thing that's happening to x and y is that there's maybe a coefficient or I'm adding or subtracting to it. But I'm not taking a number and dividing it by x. Nothing like crazy. Slope, okay, we can find that slope of a line. Okay, so that would be your, actually, let's undo that. I don't like that one. What if I made it a positive? Okay, this would be more of our rise over run here. So rise over run. Or we do our equation y2 minus y1 all over x2 minus x1. Maybe that's kind of ringing a bell. And rate of change, a lot of times we calculate from a table or like another graph but with labeled axes. So first let's look at identifying linear equations and whether or not they are linear. So in number 1, so far so good. I've got 5x plus 3. Great. So the only thing that is happening to x is multiplication and addition. But then, okay, I see x times y. In no way, shape, or form can I multiply the two variables together because that technically gives me a degree of 2, which we haven't really gotten there quite yet. However, you can make a note of this. So this, we would say, is not linear. Okay, but in number 2, okay, so I've got 3/4 times x. So we have a coefficient, that's okay. And then here I've got y plus 8, so I'm adding to y. That's okay, so we would say, in fact, that is linear. So now let's take a minute and calculate slope from a table. Okay, so when we're calculating it from a table, it's always your change in y over your change in x. And it should stay consistent, okay? So let's see. Our change in y in the first one, I would do, in my calculator, I'm going to do 152 minus 76. And that gives me a difference of 76. And then from 2 to 4, that's a difference of 2. So that's a ratio of 76 over 2, which just reduces actually to 38 over 1. Okay, so right now my slope is 38 over 1. Let's see if it's staying consistent. So from 152 to 228, I'm going to subtract those in my calculator and I get 76 again. Awesome. And from 4 to 6, I get 2. So because it's staying consistent, I would say yes, it is in fact linear with a slope of 38. So in number 4, I'm going to do the same thing. Find my change in y. So from 6 to 12, we're going up by, I was going to say 4. We're going up by 6. And from 1 to 2, we're going up by 1. So right now my slope is 6 to 1, or we can just say 6. Excuse me. From 12 to 18, again, it's up by 6. 2 to 3 is 1. So it is still 6 to 1. And then 18 to 24, still going up by 6. And then from 3 to 4, going up by 1. So it is linear because my slope is staying consistent and my slope is 6. We can also find slope from a graph. Probably something that you remember the most of all slope. We find that by finding the rise or the fall over the run. So I'm going to zoom up on 5 here. So what I like to do is I'm going to pick 2 points if they're not already given to you. Okay, so I'm going to choose this point and this point, and I'm just going to count how much I'm rising and I'm running. So I'm going up 1, so that's my rise, over 1, 2, 3, 4. So my slope is 1/4. Now let's just say, I'm going to erase this. Let's just say you're like, well, wait a minute. They gave me 2 points. They gave me this point and this point, and you could still find the exact same slope that way. So my rise is 2, and my run is 1, 2, 3, 4, 5, 6, 7, 8. And notice how that still reduces to 1/4. So looking at number 6, right off the bat, I know this is negative. Okay, so I know slope immediately is negative. I read a graph from left to right, and I notice I'm going down. Okay, so I went down 1, 2, so that's -2, all over 1, 2, 3, 4, 5. Now number 7, interesting. Okay, I notice it's a horizontal line. So again, I'll do rise over run, but I'm not going up any. So I'm just going up 0, but I'm running 2. So that has a slope of 0. And then number 8, okay, you could argue that I'm rising 1, 2, 3, 4, 5, 6, but I'm not running at all. And as this is a fraction, I'm not allowed to have 0 on the denominator, so we call this undefined. All right, next page. So another way we can find slope is by using the slope formula. And that slope formula is going to be y2 minus y1 all over x2 minus x1. And all that means is my second y versus minus my first one, and my second x minus my first one. So my first example, a lot of times what I'll do is I'll just kind of label this as x1 and y1, and this is x2, and this is whoops. That is y2. And so now I'm just going to plug that into my formula. So now I have 3. Now notice how you've got minus and negative. Always use parentheses all over -7 minus, whoops, oh my goodness gracious, minus -4. So this is going to give me +6 because we end up adding. And then -7 really plus 4 is -3. So that reduces to -2. In number 10, I would do -2 minus -8 all over 1 minus 9. So it's -2 minus 8, okay? And then 1 minus 9. Sometimes that's a nice visual. And so that minus negative again turns to a plus. So -2 really plus 8 is 6, and then 1 minus 9 is -8. I always reduce. That reduces to -3/4. Now number 11, I would do -17 minus 17. That is not 0, by the way, in case you're wondering. And then I'm going to do 1 minus 10. So 1 minus 10. So this is going to give me negative, let's see, 34 all over -9. So double negative here. I like this problem. This double negative cancels out. Okay, and so my answer is actually 34 over 9. And then finally, number 12, I'm going to do 9 minus 0. So 9 minus 0 all over 5 minus 5. So that gives me 9 over 0. So I have 0 in the denominator again. Okay, what does that mean? That means undefined. You cannot divide a number by 0. Now, what happens if I have to maybe work a little backwards? Okay, so what if I'm given slope and I'm going to find the missing piece to that? Well, we can use proportions to figure that out. So I'm still going to use my equation. Okay, I'll do y minus -5. So y minus -5 all over -5 minus 5. Supposedly, that equals, and I'm just going to apply the negative to the 9, -9/10. And so now I'm going to simplify this. Let's kind of like make this smaller. So this actually just simplifies to y plus 5. And then negative 5 minus 5 is negative 10. Is equal to negative 9 over 10. And now I'm going to cross multiply. So that gives me 90 equals 10 times y plus 5. And I'll go ahead and distribute the 10. And we'll solve for y. So I subtract 50. Uh-oh, kind of running out of space here. So that gives me 40 is equal to 10y, and divide by 10, and I get that y equals 4. So same concept for number 14. I'll do 0 minus y all over negative 3 minus negative 6. And that supposedly equals 0. Okay, this is interesting. So I'm going to put 0. Let's put it over anything. I can put it over 1, okay, because that's still 0, right? So let's simplify this. So I still have 0 minus y all over. Now this is going to reduce to 3 is equal to 0 over 1. So we'll cross multiply, right? That gives me 0 is equal to, I've got 1 times 0 minus y. And I'll distribute the 1. Okay, so I get 0 is equal to, well, 1 times 0 is 0, and then 1 times negative y is just negative 1y. Divide by negative 1. And I get this kind of a funny problem that you'll just get that y is equal to 0. That's it. And then finally, number 15, I'm going to do negative 9 minus 7 all over, and then 0 minus x. So this time I'm looking for an x value, and that's on the denominator, all over 16 over 3. And now I'm going to simplify. So negative 9 minus 7 is negative 16 all over 0 minus x. Then I'll go ahead and I'll cross multiply. So let's see. So 16 times 3 gives me negative 48 is equal to 16 times 0 minus x. And I'll distribute that 16. So now when I distribute to the 0, that's just 0. I don't need to really do that. But I'll distribute it to this, negative x. So it's negative 16x. Then I'll divide both sides by negative 16. Let's see. That will give me positive 3. So x equals 3. All right, and then the final part of this video is that we're just going to give meaning to slope here. So in number 15, it says use the table to find the rate of change. Explain the meaning of the rate of change. So rate of change, again, that's just another word for slope. What is my slope and what does it mean? So it's my change in y over my change in x, right? Okay, so my change in y, so I'll do 152. We actually already did this one, and we get that it's 76 over 2, okay? So that 76 over 2 reduced, if I'm not mistaken, to 38, okay? 38 over 1. So if I'm looking at this, this is 38, this is my distance in miles, per hour. So what this tells me is I am driving at 38 miles in 1 hour. And then number 17 says the table shows the cost changes with the number of minutes used. So we're going to find the slope. So let's see, it's my change in y. So from here to here is 1, and from here to here is 20, and it stays consistent. Here to here is 1, here to here is 20. So my slope is 1 over 20. So now I'm going to put my units in there. So my units for the 1 is $1, and my units for the 20 is minutes. So what that means is that for $1, well, we can say I can use or talk for 20 minutes.